Okay, last video we understood the centripetal force. Okay, and also Newton's law. All right. So now we are going to understand Newton's observation. Okay, what Newton's observation regarding the gravity? How he discovered it? Okay, so first of all, he was sitting under the tree and the apple fell down, all right, from the apple tree. So he thought that why apple fell down only, not any other direction, not even in the upward. So this is the observation, and from that observation he declared these three laws. Okay, so because of that, what is mean? Because the earth attract toward itself. Okay, earth attracts it toward itself because it fell down to the earth, not anywhere. That's why. What is next observation? Apple attract the earth. It's not only about the apple. Okay, it's about every single thing. Every single thing in this solar system, even you can say that. Even on the earth, every single thing attract the earth. Right? Next, the Newton's law of universal gravitation. Okay, so from this observation, he found the universal gravitation's law. Okay, and now we are going to understand this law. This is very important law for further study also, and very interesting also. Okay, so here is the term that used in this law are force, mass, distance. Okay, force, mass and distance, these are uh, depend to each other. For we understood in the previous standard or previous lesson that if mass is more or weight is more, then we require more force. Okay, and of course I'm giving you one example, the example of this only. So what I will do from this example, based on this example, this is the center point. Okay, now I'm going to make a long string. Then what happen? Require more force to make this circular path, right? If it's like here, then it can make easily, right? It can make its circular path easily with little force by the hand, but I attach little bit more string to this ball. It requires more force to keep it circular way. Yes, so distance is also important. Okay, all right, so this is the Newton's observation. It's require force, mass, distance. All right, so let's see the statement of the Newton's universal gravitation law. Okay, let's see. Every object in universal attracts every other object. This is simple, but you have to understand it, so you can write it by your own word also. Every object in universe attract every other object, okay, with the force directed along the line of center for the two objects. What is considered center point? It has to be considered that attract is there, but from where? Right, from the center point here, as we understood up here. Okay, so every object in the universe attract to other object and directed from where? From the line of the center. Okay, for the two objects, we will see this with a diagram also. Okay, but first we understand the statement. Okay, so what is that? For the two objects, that is proportional to the product of their masses. Proportional. Okay, proportional to the product of masses and inversely proportional to the square of separation. Okay, inversely proportional to the square of the separation between two objects. Separation means what? Separation, if these two objects are separated, so separated by with reference is distance you can say radius, you can say it's all same. Okay, so first point we understood that every object in universe attract to other object. Second point, what is second point? The line of the center. Okay, it's directed with force is there, force is very important, but comes from where? Directed along the line center. Okay, with two objects, talking about two objects only, only two objects. And third point is directly proportional to the masses and inversely proportional to the separation between two objects. Instead of this, you can also write inversely proportional to the square, right? Square of its distance between two objects. You can also write that. Okay, so this is the universal law of what? Gravitation. Okay, now let's see here. This is two object, right? Okay, this is the two object. All right, now what is the first point? Attract to each other. Yes, any object attract to each other, so these are going to attract, but it has its own mass m1 m2. It has its own mass m1 and m2, right? This is the distance, or you can say also separation, and this is the force applied. Force with respect to what? The attraction, right, between two objects. So this is the force toward it. This is the separation, and object has a mass m1 and m2. Okay, so this is the term d distance, m1 and m2 is mass, m1 for object 1, m2 for object 2, and f is force. Okay, now here is what? Directly proportional to the mass, right? So f is directly proportional to the m1 and f directly proportional to the m2, m1 and m2. So we can write like this: f is directly proportional to the m1 and m2. Okay, now what? Now distance, or you can say separation. All right, here distance we can also consider as a r, right? Radius. Okay, why? Because we are doing this equation or this all concept with the reference of center. Okay, center, that's why we can take r, radius. All right, and the force is inversely proportional to the square of distance, or you can say separation of these two objects. So this is the r and its square, so it is r square, right? So at the last, what we will get? Force is equal to m1 product m2, m1 m2 inversely proportional means r square. Why here is r square? Because we are calculating from this m1 to m2, and we are also calculating m2 to m1, from here to there and from there to here twice. That's why it's square. So f is equal to m1 m2 upon r square. Okay.